All right, continuing with our Unit 2, Day 8 video lesson for our absolute value inequalities, we're going to look at something slightly more complicated. So this is an inequality, this is an absolute value equation, right? Because it's got an equal sign, not an inequality. So remember, we have to isolate and split. Well, the absolute value information is already isolated, so now I'm just going to split. On the left side, I'm just going to rewrite that entire equation without the absolute value bars. That's going to be one solution. On the right side, I'm going to rewrite the stuff inside my absolute value, but I'm going to say it could equal -5. Because if everything inside my absolute value bars equals -5, and I take the absolute value will be 5. Now I'm just going to solve, so I subtract 1 from each side, and I get 2x equals 4. Divide each side by 2, I get x equals 2. This is one answer, but there is probably another answer, so I'm going to check. Over here, I'm going to subtract 1 from each side, I get 2x equals -6. Divide each side by 2, and I get x equals -3. I have two answers that will work for this absolute value equation. Two different answers, they both work. If I plug in 2, I get 4 plus 1 is 5. The absolute value of 5 is 5. If I plug in -3, I get -6 plus 1. That's -5, but take the absolute value of -5 and you get 5. So when we're working with our equation, I have one answer right here at 2 and one answer right here at -3. Those are my options, just those exact numbers. All right. But if I have an inequality statement that has absolute value, it's just a little bit more complicated. Okay, I'm thinking to myself, this is the absolute value of 2x plus 1 has to be less than 5. So what are all of the numbers that I can have inside that absolute value bar that would be less than 5? That's what I'm thinking about. Okay, so I'm going to first just rewrite 2x plus 1 is less than 5, just like I saw it here, except I got rid of my absolute value bars. With an inequality statement that has absolute values, my second part is going to be 2x plus 1. Okay, I'm just getting rid of my absolute value bars, but I have to switch my sign and change my answer to a negative. If I started out with negative, I would change my answer to a positive. All right, so now I have two inequality statements that I'm going to solve. Subtract 1 from each side. I have 2x is less than 4. Divide each side by 2, and I have x is less than 2. That is one part of my statement. Okay, over here, 2x plus 1 is greater than -5. I'm going to subtract 1 from each side. 2x is greater than -6. Divide each side by 2, and I get x is greater than -3. So that is my other piece of information. Now, when we split this, we have the word "and" here. So I need things to be both less than 2 and greater than -3. I can rewrite this information in numerical order, and it'll look like -3. I want to get smaller as I'm going toward -3. So -3 is less than x, and also x is less than 2. Okay, it is a compound statement. It has information about x. X is in between -3 and 2. So I'm going to come up here and I'm going to say -3 and 2. Those are my boundaries. I want all the stuff in between. Okay, x has to be greater than -3 and it has to be less than 2. Now, I use an "and" statement here, and I'm going to give you top secret information that's on your next page. I see this symbol right here. This is telling me the absolute value is less than 5. Okay, so here's the top secret. Less than. Instead of writing "than," I'm going to write "than," because if the absolute value is less than a number, then it's going to be an "and" statement. If the absolute value information is greater than a number, it's going to be greater than. So instead of greater, the way we normally spell it, I'm going to say greater than, greater. And so I know this is going to be an "or" statement. Okay? My absolute value here is less than a number. Less than, I know it's "than," I know it's an "and" statement. This absolute value information is greater than a number, and so it's going to be an OR statement. All right, back to solving inequalities that have absolute values. I'm going to bring my first information down, just get rid of those bars and keep everything else the same. With my second statement, I'm going to keep the absolute value information the same, but get rid of my bars. I flip my sign and I make my number the opposite sign. So this time it's going to be negative. Okay, it's OR statement because we were greater than 5. So I'll subtract 1 from each side. I have 2x is greater than 4. Divide each side by 2. X is greater than 2. That's one part of my information. Over here, subtract 1 from each side. I have 2x is less than negative 6. Divide each side by positive 2. I'm dividing by a positive, so I'm not flipping any signs here. X is less than negative 3. That's the other part. It is OR. It's an OR statement, right? So I'm going to possibly be going in opposite directions. X is greater than 2. Here's 2. X is greater than 2 goes that direction. X is less than negative 3. Here's negative 3, and I want things that are less. So since it's an OR statement, as long as I'm greater than 2 or I'm less than negative 3, I'm going to be good to go. All right, so one more time, if my absolute value information is isolated and it is less than a number, I'm going to have an AND statement. I need information to be true for both parts. So solving something like this, x plus 5 in absolute value bars, all of that is less than or equal to 1. When an absolute value is less than a number, the inequalities, the inequalities are connected by the word AND. Okay, so what it means is that anything that I have inside those bars, the absolute value of it is going to be less than or equal to 1. So I say the absolute value of x plus 5 is less than or equal to 1. I bring down my split. I have x plus 5 is less than or equal to 1. Subtract 5 from each side, and I end up with one part of my information, x is less than or equal to negative 4. X plus 5, if that information in my absolute value bars, if it's negative, I'm going to say x plus 5 is less than or equal to 1. That's my original statement. I'm splitting. I'm going to change the direction of my sign and make my number the opposite sign. So it's going to be a negative now. I will subtract 5 from each side, so I have x is greater than or equal to negative 6. Okay, I'll go through and do each of these problems one step at a time on the next video so that we can practice and you can try to solve each one and then check your work. Just pause the video as you need to.